This video is going to give you a little bit more information about what water sensitive design is actually about. You'll recall that in the previous video we talked about um, traditional drainage systems being completely different from the way natural systems handle water. And so the aim of a water sensitive design is to try to be as closer to nature, the way that nature handles water, because it works out better for local ecosystems and water bodies. So let's just look at things before development. So here's a nice bush laden hillside. The rain falls down on the hills. The trees buffer the rain, so there's and the vegetation holds the soil together. Um, Depending on the type of soil, the a certain amount infiltrates into the ground and becomes groundwater, which eventually flows to the local water bodies. The rest of the water flows across the land into the water bodies, but as it flows across the land, it also uh, gets treated a little bit. Some of the gross particles in it, the chunks, if you like, are filtered out by the grass and the vegetation. Also, there's biological processes going on, which are sort of killing off some of the um, microorganisms that might be in it or something like that. And also, the ground is quite clean. There's no toxic chemicals or anything sort of lying on it. So what happens when we put in a traditional developed system? What we do is, first of all, we're putting in a whole lot of uh, uh, areas with low permeability, like roofs and roads and stuff like that. And so the water, instead of soaking into the ground, sheds, goes across the ground. It's in the traditional system, we collect it with pipes, and the idea of a pipe system is to move it into the water system as fast as possible. Several effects. First of all, there's this water going into the groundwater, and there's more flow going across the ground. The stream sees a much higher inflow, a peak inflow during the rainstorm, rather than having the water sort of meander its way through over a period of time. So we talked about that in the previous video. The two main problems are the pollutants that the surface water picks up, and the fact that the quantity of water is higher than what was before. So what's water sensitive design is that we design our water collection systems to be more closer to natural systems. So we have um, trees, for example, sort of open areas which allow the water to soak into the ground. We also have systems which buffer it, which hold the water in the system. So we're going to talk about rain gardens and things like that. They hold some of the water in. So the flow that is going to the water bodies is slowed down considerably. Instead of having a whole lot of water all coming in at one go, you've got the same amount of water coming in over a period of a few days or something like that. So the stream doesn't get that big peak flow that we sort of saw before. And that's what's shown here in this video, in this thing here. So there is our traditional system. There is what things were before. And this is what happens when we put a water sensitive system in. The flows are buffered to match those that the pre-development as well. That's called hydraulic neutrality. And what the stream sees is it doesn't see flow, it doesn't see these big flows, it just sees these little flows. So it's able to contain the flow within its banks without undue erosion or other damage sort of happening. It also means that the 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 fish and the plants that are living in the stream don't see the high velocities that you would get with this sudden influx of flow. The velocities they get, the stream pretty well feels like what it was before the development. So that's what we're trying to achieve, one of the things we're trying to achieve with the system. The other thing we're trying to achieve is to treat it, to remove some of the contaminants that are in the water as it moves across the land. So there's screening. So the gross particles get caught on the screen or grass, just as the way would happen if water is flowing across grass. It sort of screens it. The gross particles get caught in, in the grass or the screen. Filtration, you can have filter media. So this is what would happen if it's flowing through through the soil or something like that. Once again, the gross the big particles in this water can't get through the small gaps and they get stuck there. Sedimentation. So if the water is sitting there for a certain amount of time, the solid particles that are in it will start to sink down. And if you decant off the top layer, then you can be decanting off cleaner water. I've repeated filtration. Got it twice because it's so important. Infiltration, this is where the stormwater soaks into the ground. So that when it soaks into the ground, it moves through the ground, and that's where filtration and buffering sort of happen. Adsorption, dissolved substances stick onto filter particles. So this is at smaller um, smaller scales. And decomposition, when you're moving it through a natural system, there are natural bug microorganism communities that will prey uh, on organic materials or break them down or decompose them. But also, if there are any pathogens, microorganisms that can cause harm to humans, they're also predated upon. They're hunted, killed. So um, being able to emulate the natural system means that um, you're going to get much better outcomes. You're going to attenuate or reduce the amount of flow that's actually going into the stream at any particular time, and you're also treating the water. So you're taking care of the quality, which is the removing pollutants, and the quantity, which is the attenuation. We'll be looking at the components you have in a water sensitive system in a later video.